right. So, yesterday we talked about direct variation. Remember, direct variation was when you had y equals some constant times x. So your equation looks like y equals a x. And a cannot equal 0. Your constant of variation cannot be a 0. It can be a negative, it can be a fraction, it can be a whole number, but it cannot equal 0. What did my graphs look like for direct variation? A straight line. Okay. What specific point did it have to go through though? 0, 0. It had to go through your origin. So your graph could look something like this, or it could look something like this.
What does that sign mean? How you do?
Okay, so when the graph goes up and to the right, that means your A value is greater than 0. It's a positive number. It has a positive slope. If it's going down to the right, that means we have some kind of a negative number, so your A value is less than 0. Inverse variation is going to draw the graph of a hyperbola.
What?
What? It's called a hyperbola. Okay, so direct variation was where we had y equals a times x. What do you think inverse variation is going to be? Divide. Okay, so we have y equals a divided by x if it's inverse variation. And again, your a value cannot equal 0. It has to either be a positive number, it could be a decimal, it could be a negative number, but it just cannot equal 0. Okay, so again, your graph's going to look like a hyperbola if you have an inverse variation. So let's say your a value is positive, which means it's greater than 0. Your graph's going to look like this. It's split into 2 separate pieces. Notice that it doesn't touch your y-axis. Do you know why?
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 What can your x value never be?
0.
Why?
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 Why can it never be 0? You can't divide by 0. 10 Commandments of Math, your first one. I don't know if you've ever seen my 10 Commandments of Math up here. The first one, thou shalt not divide by 0, ever. You can't do it. That's why your graph will never, ever touch your y-axis. Because your x value can never be 0 in the bottom here. Okay, if I switch it up, and I make your a value less than 0, which means your a is now negative. All it does is it flips your graph. So this one that was up here is now over here, and the one that was down on the left is now down on the right. And again, that graph is called a hyperbola. Questions on what they look like from a graph?
No, ma'am.
Okay. If you open up the next page, we need to look at equations. Please stop talking. Why is it so hard to be quiet? Okay, you're going to need to be able to look at an equation and tell me, is that direct variation, inverse variation, or neither? Okay, so as long as you are dividing by one of your variables, it is automatically inverse. Okay, remember you cannot have a b value. And if for some reason both of the
2 cups. 2 cups. Hello?
Did you turn it on silent?
Yes.
Thank you. Okay. If for some reason both of your variables are on one side of the equal sign, do get one on the other so you can decide what it is. So if you take a look at number 1, I have x equals -4 divided by y. What kind of variation is this, or is it neither?
Inverse.
This is inverse. Even though we're dividing by y, it's still inverse. You're dividing by one of your variables. So this is inverse variation. Take a look at number 2. Y equals x minus 2. This one is neither. Why? You've got that minus 2. You've got that b value there. So this is neither. A. Okay. Number 3. You got xy equals 6. Before you can compare, I need to take one of those variables to the other side. Does not matter which one. Which one would you like to move? X. How do I do that? We divide. So I divide both sides by x, which means I'm left with y, and on the right, I'm left with 6 divided by x. Now what is this? Inverse. On the right-hand side, number 4, y equals 8x. That is direct.
Oh my God. How is it down? Oh my God.
Okay. Down here, can you write the inverse variation equation based on the information that they give you? Okay, so just like direct variation, where it says directly, it's y equals k times x. When they say inversely, it's y equals k divided by x. You are going to need to memorize those equations. They will not be provided for you. Again, you get no formula sheet for your final exam. Okay, so what we're going to kind of do towards the end is what I call a dump sheet. Okay, you all get out a separate sheet of paper. You'll throw down every formula you've ever learned in math. I don't care what it is, Pythagorean theorem, whatever. That's what I want you to do before you even start your final. That way, as you're going through the problems, you've got a reference sheet. Okay? And you're not sitting there thinking, oh, wait, we learned that here, there, what. Everything's right in front of you if you create a dump sheet. Okay? So we'll do that towards the end. So number 5 says the variables x and y vary inversely, and y is 5 and x is -2. So as soon as you see this word inversely, you need to write y equals k divided by x. Now they tell you y is 5 and x is -2. So you're going to plug in 5 for y. You don't know what your k value is, and you're going to plug in -2 for x. At this point, we now need to solve for your k values so we can write your equation. If I want to get k by itself, how do I move that -2? Multiply. It's being divided, so to get rid of it, we multiply. What you do to one side, you do to the other. So we have -2 times 5, which is -10 equals, these two cancel, so -10 equals K. So then your final step then is to take this and plug it in for K and write your equation. So your final equation is y equals -10 divided by X. And then if they tell you when y is 2, find your X, you can plug in and solve from your equation. Your thing is, though, you have to create your equation first before you can solve. So number 6, variables X and Y vary inversely. So we stop there and write y equals K divided by X. We're varying inversely. Now they tell us y is 9, so we plug in 9 for y. We don't know what K is, and they tell us X is 5. So when I get rid of that 5, I do what? Multiply. So what is my K value then if we multiply by 5? 45. So your final equation then is y equals 45 divided by X. You just notice that you do every time when you're solving for K. We multiply. So guess what? In your table, that's what we're going to do as well. Remember yesterday when we took y divided by X and we had to make sure all of our constants were the same? We're going to do the same thing, but because this is inverse, instead of dividing, we're going to multiply. So what is 4 times -5? -20. What is -4 times 5? -20. What's 1 times -20? 2 times -10. And 10 times -2. Okay, when all of these match, that is your K value. Create your equation. So y equals -20 divided by X. So you still need to look for that same constant of variation. But instead of dividing, we now need to multiply. So try number 8 and see if you can find the K value and come up with the equation. Remember, if the numbers keep ending up the same, you must keep going on. Please make sure that the entire chart is the same. They may switch it up clear at the end just to see if you're going to go that far. And if you stop before that, you're going to tell me that I have an inverse variation when I really don't. So please check them all. Don't assume. Okay. What did we find our K value was here?
12.
12. Every time you multiply, you get a value of 12, which means my equation looks like what?
Y equals 12 divided by X.
Fantastic.
Fantastic.
Super duper. Okay. If you flip it over, we've got 4 more examples, and then you guys are going to work on. It's better than listening to me talk all period, isn't it?
Wait, where did you go?
Okay, so the shape of an inverse equation. is called a hyperbola. So that first blank there is hyperbola.
Where is this at?
Hyperbola.
Where is this at? Oh,
You stapled it wrong, didn't you? You
no.
folded it wrong. Yeah, because we should be on the last half.
Oops.
Oh, man.
Getting your hairbrush, getting even staple it right.
That's bad.
What
He
is
folded
this?
that middle page wrong, didn't he?
What happened?
Okay. The two pieces of your hyperbola are called your branches of the two symmetrical pieces. So what's happening on that top right corner will mirror image what's happening on that bottom left. Okay, it reflects over the line y equals x, or if it's opposite, it'll reflect over the line y equals negative x. So we're back to transformations. Clear back at unit 1. And remember when I told you that your graph will never touch the y-axis because the x value cannot be 0? You'll talk more about this in Math 3, but these are called asymptotes.
What?
Name on it, that kind of
Toes. Where does these words come from?
Asymptotes.
Asymptotes. Asymptotes.
ASYMPTOTES. Okay. All those are is a line that the hyperbola is going to approach. So it'll get really, 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 really close to it, but it's never going to touch it. So in the basic inverse, your graph will never touch the x-axis or the y-axis. Those are your asymptotes in basic inverse functions.
Isn't that how you pronounce it?
What? Hyperbola.
Hyperbola.
I still have kids to this day pronouncing it hyperbola.
Hyperbola.
You sound like Bubble Man from.
Okay, so graph the inverse variation equation. Okay, when it's written like this, think about it this way. X times y equals 8. What values can I multiply together to give me 8?
1 times 8. 1 times 8.
1 times 8. So I can graph 1, 2, 3, 4, 5, 6, 7, 8. The point 1, 8. Or if 1 times 8 works, so does -1 times -8. Remember that mirror image. So if +1, +8, we can go -1, -8. What else? 2 and 4. So I can go +2, +4. If I do +2, +4, I can also do -2, -4. Okay. Are there any other 2 numbers? Okay. Now, also, if I can do 1 times 8, I can do 8 times 1. So I also have 1 clear out at 8, comma 1, and -8, -1. We also did 2, 4, so I can also do 4, 2.
I didn't.
So 4 comma 2 or -4 comma -2. I would go for at least 4 dots on your graph before you draw your line. So now that we've got this, your graph comes down and curves around in the top right, and it comes down and curves around in the bottom left. Okay.
It's all positive. Oh my god.
Okay. Number 10. X times Y has to equal -6. So what can I do? What two numbers will multiply to give me -6? -2 and +3. So I can do -2 and +3. So -2, +3. If I can do -2, +3, I can also do, okay, +2 and -3. I can switch my signs. Okay. I can also switch where these numbers are. I can do 3, -2, because that also gives me -6. So 3, -2. I can also switch my signs. -3 times +2 will give me -6. What other two numbers multiply together to give me 6?
1 and 6.
1 and 6. And again, because this 6 is negative, I've got to do -1 and 6. Which means I can flip my signs and do 1, -6. And I can also switch up my numbers. I can do 6 and -1. And I can do -6 and +1. So you've got this part of your hyperbola and this part of your hyperbola. Okay.
You made Charles disappear.
I made him disappear.
Yes.
What am I, a magician? Okay. If you like the way we did that one, you can also make this look like that. Y equals 5 divided by X is the same thing as X times Y equals 5. So, what two numbers multiply together to give me 5? 1 times 5. So, I can do +1, +5. 1, 2, 3, 4, 5. Or -1, -5. So we can do 1 times 5 or -1, -5. Don't forget, I can switch these. 1 times 5 is the same thing as 5 times 1. Or -5 times -1. This one we have a problem though.
Houston, we have a
This is a
problem.
straight line.
It's not technically a straight line. But the problem is there's no other pretty whole numbers that multiply together to give me 5.
Right.
We can start with halves. So 2 times what gives me 5? What's 5 divided by 2? 2.5. Okay, so I can do the point 2 comma 2.5. Okay, so you go to the right 2 and up 2.5. So not all of these are going to be pretty. If there's no whole numbers, you have to resort to the decimals.
No.
Okay. I can also then do -2.5, comma 2 in the negatives, as well as 2.5, comma 2 in the positives.
Hello?
Tell me, baby.
Okay. So you still have that slight curve here to create your hyperbola. And that slight curve here to create your hyperbola. Okay. And finally, number 12. Again, I can rewrite this as x times y equals -9. So what two numbers multiply together to give me -9?
3 times 3.
3 times 3. Remember, 1 needs to be negative because I need a -9. So I can do 3 times -3 or -3 times 3. So 3. Notice my scale is by 3s here. So they didn't have to make the graph so big. So 3 times -3 is actually right here. Okay, so watch your scale. And -3 times +3 is right here. What else can I do? What other two numbers multiply together to give me 9? 1 and 9. Okay, again, I need to make one of them negative. So 1 times -9 or -1 times +9. 1 times -9.
For math is so extra.
Math will be extra for the rest of your life.
But you needed to count that money.
Right. You needed to count that money when you ballin'. Okay. I can also do -9 times 1 or +9 times -1. It still will give me -9. So -9 and +1 or +9 and -1. Okay. Even though we don't have 4, we've got a pretty good idea of what this is going to look like. Yes. Can you let me finish these notes real fast and explain what you're going to do next?
Yes.
Okay. Okay, so that graph should look like this.
Vámonos, amigo.
What I need you to do right now is glue this in on page 94, and we are officially done with unit 3.
Lobo.
Lobo.
Bro, I just glued this in yesterday. What page is this on?
94?
Yeah, that's what page we're on, right? 94?
Here.
Look, 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 look.